network devices. Let's start with the router. To understand the network devices, you need to be familiar with OSI model. Okay, that's why I discussed OSI model first. If I talk about a router, I will see when we will learn routing, I will tell you different models of routers. Okay, their hardware components also like RAM, ROM, flash, bootstrap program, mini iOS, Roman mode. Okay, how to upload iOS in the routers, how to perform password recovery. Okay, if the iOS is crashed, then how to recover it or how to upload the new iOS when you don't have any iOS in your Cisco devices. Okay, iOS is the inter operating system. It is called inter operating system of it is the operating system of your Cisco routers and switches, Cisco iOS. Okay, inter network operating system. Now, if I talk about, see this term, whenever you are using Cisco iOS or I am using Cisco iOS, it means I am talking about Cisco router and switch operating system. Okay, so if I talk about a router is a layer 3 device, right? It works at network layer. So it is a layer 3 device. It is used to create communication between different network users or different network endpoints connected in same geographical location or different geographical location, right? Regardless of their geographical location. Okay, so router is a layer 3 device. It is used to create communication between different network endpoints connecting in same geographical location or in different geographical location. Router takes forwarding decision or router forwards the packet based on destination IP address contained in IP header by performing lookup into its routing table. Okay, into its routing table. If the router has the route, now what is route? Route is the best path to reach particular destination network. Has the route to reach destination network, then packet will be forwarded, right? Otherwise, router will drop the packet. Router will drop the packet. Okay. Now, how router can create the routing table, right? So router can create the routing table statically, means you can create the routing table statically, or you can create the routing table dynamically also using dynamic routing protocols. We will see them, we will configure them on Cisco devices, on Cisco routers and firewall also. Okay, clear? It has a broadcast domain on each active interface. What is broadcast? What is unicast? And what is multicast? These are data transmission modes, right? Communication modes. Broadcast, multicast, and unicast. Broadcast means one to all. Means one will be the sender, all other endpoints will receive it. Okay, it is called one to all. Broadcast means one will send, all other endpoints connected in the network will receive that particular data or request. Okay, this is called broadcast. And multicast means when you are having a device who is sending the data and multiple endpoints can receive the data, not all the endpoints. Okay, there is a difference between all and multiple. Okay, all means there is no grouping of the users. If the user is in the broadcast domain, then it will receive the data sent by any other user in the same broadcast domain. But if I talk about multicast, then multicast group will be created and a multicast address will be assigned to that group. If the communicating endpoints are this part of that multicast group, then only they will receive the data for that multicast group. Otherwise, they will not be able to receive it. It is called one to many, not one to all. Okay. Multicast communication method is called one to many.
So,
Broadcast is called one to all. You can
what is the
consider it like this. Yeah.
what is the difference between one to all or one to many?
Okay. Let's say here I have a router connected. Okay. And here I have R2 and R3. Okay. If I am connecting them like this, then if I enable any routing protocol or multicast routing protocol which uses address 224.0.0.10, then this multicast address will be listened by both of the routers. If you enable that protocol like EIGRP is used, EIGRP uses this multicast IP address. Okay. So whenever R1 will receive the packet, whenever R1 will generate the packet for EIGRP protocol, it will be received by R2 because EIGRP is enabled on R2, and this R2 is the part of this multicast group, okay, which is listening on this IP address. So this R2 will receive the packet, but R3 will not receive the packet, okay. R3 will not get this multicast packet because it is not the part of this multicast group, which is, or you can say, which listens for IP address 224.0010, right? This is called multicast, means only the routers, only the devices which are the part of this multicast group, they will receive that particular packet which is sent to the multicast address, right? Because
Within the
they are
subnet.
listening. Yeah, not within a subnet. Okay, it is not for always within a subnet. You can say if that particular multicast address is in listening mode for that particular endpoint or network device, then that endpoint or network device will receive the data for that multicast traffic, for that multicast type of IP address. Okay, otherwise it will not receive it. In broadcast it is different. Okay, in broadcast it is like this. We have this PC, or you can say we have this router, and it is connected with a switch 1, and here we have R2, here we have R3. Okay, so now when the switch will generate any broadcast, it will be received by R2 and R3 both, if
At a
they are
time.
the part of same broadcast at a time. Yes, this is called broadcast. And unicast means one to one communication, like this. This is unicast communication. Not, this is not unicast means not point to point. Okay, point to point is not unicast. It is like this. This is unicast. One to one communication. Okay. In
Yes.
multicast traffic, we use multicast IP addresses as the destination IP address. Okay. For unicast, destination IP address will be the user's IP address, right? And for broadcast, destination IP address will be layer 3 broadcast destination IP address will be 255.255.255. Clear? If this router is generating any broadcast request, it will be received by all other devices connected in same broadcast domain. So if I talk about a router is a layer 3. So on a router, we have a broadcast domain on each and every active interface. Okay. That's why when you are going to connect a router in the network, let's say this is router 1. Here I am connecting a switch, for example, and here I am connecting a switch, for example. Okay. So this router will have two active interfaces. This is switch 1, this is switch 2, this is E0 by 0, this is E0 by 1. So if behind this switch you can connect a PC just to show a connected endpoint, and behind this switch you can connect a server. Now when this PC will try to communicate with the server, it will send the traffic via these switches and this router, right? So on this router we have two separate broadcast domains. That's why we have to define different network IP addresses on each and every active interface of the router. Okay. You cannot define same network IP addresses on these different interfaces of the router. Clear? Whenever we use routers in the network, we need to configure IP addresses on them. And on routers, we have a broadcast domain on each and every active interface. So we have to define different network IP address on each and every active interface. We cannot use same network IP addresses on two active interfaces of the routers. Okay. Whenever your broadcast domain will be changed, it means your network is changed. If I talk about the protocol, it always depends on your communication data. Okay, when you are going to send ping packets, you will use ICMP protocol. When you are going to send web traffic, you are going to use HTTP protocol. Okay, it depends on your endpoints. Okay, when you are just sending telnet or SSH data, then telnet SSH protocols will be used. Let's say this is PC1, it is connected with a switch, then it is connected with a PC. Now switch will be used to create the communication between same network devices, right? Let's say here I am using 10.1.1/24. On this PC I am using 10.1.2/24. They are same network users, right? Their parent network will be 10.1.1.0/24, right? So they are same network users. If you want to perform RDP, you want to take remote desktop connection of this PC on this PC, then you can take, they are in the same network, right? So they can communicate directly via this switch only. You don't need any router. But, and you can say that they are the part of same broadcast domain. Okay, I will tell you about this. You can say they are the part of same broadcast domain. But here, if I talk about a router, let's say this is a PC, and here I am connecting a router directly, and here we have a PC. Okay, so this is a different broadcast domain. This is a different broadcast domain. Between this PC and router, you have to use a different network IP address because broadcast domain is different, and here you need to use a different network IP address because a different broadcast domain is being used. Here you will configure .1.1. Here you can configure .10.10, right? Now this router will create a routing table. It is using the protocol to forward the data, but to create the routing table, it will use routing protocols also. Okay, but for now, these two networks are directly connected. So their routes will be added in its routing table automatically. Okay, like this 10.1.1.0, it will show directly connected with this router with interface E0 by 0. Okay. Then one more directly connected network will be there 10.1.2.0 with interface E0 by 1. When R1 will receive the traffic for any of the destination network, it will perform routing lookup, right? And it will get the route to reach the destination network. When PC1 will try to communicate with PC2, let's say it is using RDP, remote desktop protocol, to take remote access of this PC, right? Then this R1 will only send the traffic based on destination IP. It doesn't care about the protocol. Okay, it will care about the protocol when it comes to filtering, but for now, for the packet forwarding, it only checks for the destination IP. Now when this PC1 will try to perform RDP connection to PC2, then it will create a packet, right? It will create an RDP packet. Let's say this is your RDP, this is your data. With this RDP packet, source IP will be 10.1.1, whatever it is, 10.1110. Okay, on this PC it is 10.1110. And on the destination PC it is 10.1.2.10. This will be the destination IP in the IP header, right? This packet will be sent to R1. R1 will perform routing lookup. R1 will check destination IP and it will perform routing lookup. It will find a route to reach this destination network, right? It will find a route to reach this destination network, and this packet will be sent out of E0 by 1 interface. It will be received by PC. This is how router will send the packet. When this PC will reply, it will create the packet. It will become source IP from this side 10.1.2.10, destination IP 10.1.1.10, right?
Right.
And this is RDP packet, and it will contain data. This packet will be sent to R1. R1 will check the destination IP 10.1.1.10. It will check its routing table. It will find a route to reach this destination IP or destination network 10.1.1.0 reachable via E0 by 0. This packet will be sent out of E0 by 0 interface. It will get the reply packet. Right, this is how router will create communication between different networks, okay, based on destination IP addresses. This is just for connected network. We will discuss about routing when the networks are not always directly connected. Okay. Clear? Are you getting the things? How router works? Then we will see the criteria, how router will take forwarding decision, how it will find the best path, okay? How it will select the best path, all these things. We will see those attributes also, those features also, you can say. Now let's discuss about switch. So if I talk about a switch, switch is a layer 2 device or switch works at transport layer. Switch works at data link layer. It forwards the packet or frames, right? Based on destination MAC address, performing lookup into MAC address table. Now I told you that router will take the forwarding decision based on routing table, right? And it will be created by the router statically or dynamically. But MAC address table will be used by switches. Whenever switch will receive any frame, it will try to forward. There is someone drilling in the wall, I think. So it forwards the frame based on destination MAC address by performing lookup into MAC address table. Now switch will create the MAC address dynamically. Okay. Means it will learn the source MAC address of the packet of the frame to create its MAC address table so that it can use that MAC address table to forward the frames. Okay. Because when you will connect a new switch in the network, it will be an empty switch, right? There will be nothing in the switch. Okay, so how the switch will take forwarding decision? So it needs to create a MAC address table. So that MAC address table will be created dynamically by noting down the source MAC address from the packet. Okay, the switch works at a data link layer. It forwards the frame based on destination MAC address by performing lookup into its MAC address table. This MAC address table will be created by switch dynamically by learning source MAC address from the packet or from the frame. Okay, from the packet or from the frame. Switch uses this MAC address to take forwarding decision. Switch is used to create communication between same network devices. It is used for scalability. It is used to provide scalability so that we can connect more and more endpoints in the network. Because when if I talk about the router has very limited ports, limited interfaces, okay, like 2, 4, 6, okay. But if I talk about a switch, Cisco switches can have multiple ports, right, like where they are very scalable, okay. Like you can have 8 port switch, 12, 16 port, 24 port, 48 port, 64 port, okay, 98 ports switches are there. If I talk about Nexus switches, then you will get up to 300 port switches. Okay, multi-chassis switches are there, which can provide you up to 300 interfaces in a single switch. Okay, so switches are very scalable. They used to connect more and more devices in the network. Okay, and they will create communication based on MAC addresses only. You don't need to use any IP configuration if the networks, if the devices are in same network. You don't need to perform routing. Okay. Now we have two types of switches. Okay. Like we have layer 2 switches and layer 3 switches. Layer 3 switches are also called multi-layer switches. Means these layer 3 switches can also perform routing. Now we will see this switch operation practically. I will show you how switch learns MAC address, how switch creates MAC address table, how switch forward the packets, forward the frames, how switch forward the broadcast packet, how switch forwards unknown unicast packets. Okay, so all these things will be discussed in our practicals. Okay, now if I talk about more on switch, then switch has a broadcast domain by default, or broadcast domain by default, which is called, what it is called, VLAN 1. All the switch ports means interfaces, are assigned into VLAN 1 by default. So if we assign same network IP address on the endpoints connected with switch, they will be able to communicate with each other, right? It has one collision domain. What is collision domain? On each active interface. Collision domain where data can collide, right? So previously we were using CSMA CD when hub was used. Hub was a mindless device, right? It was having only one collision domain globally. So in hub there was some chances to data collision, right? That's why we were using CSMA CD. Okay, collision detection mechanism is called the CSNA CD, but we don't use it nowadays on Cisco switches. You can configure it, but we don't need that. Okay, here data will not collide. Other than this, we can say that switch has one broadcast domain by default. Means when you will purchase a new switch, it will have a broadcast domain by default. Okay, if you connect network devices, if you connect endpoint with the switch ports and you configure same network IP addresses on them, then they will be able to communicate with each other. Okay, without the need of router. If the endpoints are connected in different networks, okay, then we need a router to create communication. So we will see many other things, many other features related to switch. Okay, I will tell you different model numbers of Cisco switches which can be used in your LAN network, in your small office, home office networks. Okay, you can say they can be used in. There are some models which can be used in service provider network, data center networks. Okay, and I will show you some Cisco Nexus switches also from Cisco website itself, and we will see the port numbers or what type of different interfaces available on the Cisco routers and switches. Okay, clear? Any doubt? So this is how we are going to do the thing. So I gave you an introduction of network device like router and switch, and we discussed about OSI model also. Okay. Tomorrow I will tell you about these other network devices like WLC, access point, firewall. Okay. Just for an overview, if I talk about the firewall, then a firewall is a security system or device. Firewall is a security system or device used to monitor inbound and outbound traffic based on predefined rules. Okay. A firewall is a security system or device used to monitor inbound and outbound traffic based on predefined rules. It can provide access control, URL filtering, application visibility and control, HA, high availability, okay, malware scanning. Now in next generation firewall, we can perform malware scanning, intrusion prevention as well, VPN support, okay, etc. Many other features are there. Okay. URL filtering is included, file-based control, file analysis, okay, format-based filtering, DLP solution, data loss prevention, you can configure it on the firewall, SSL decryption, HTTPS inspection, okay. So many policies can be created. Identity-aware policies can be created based on usernames. You can filter the traffic based on security group tag. You can filter the traffic. So many attributes can be used in terms of access control, in terms of securing the networks. Okay. So we will see the different attributes when we will move to this firewall device. Okay. I will tell you about other things like here we have two types of firewall. Okay, software based firewall, and you can call them host based firewall also, and network based firewall. Host-based firewall will secure the traffic for only one host in which it is installed. And the network-based firewall will secure the traffic for all the endpoints connected in a network. Okay, clear? So we'll discuss these things in our next class. Okay, if you have any doubt in